In this video, I'm going to show you how to use a BoxCast as opposed to a line cast, and this is intended for 2D use in this demo. And ideally, we're going to use it to check when grounded, so when your character is on the ground or not on the ground, for example. So I'm going to go ahead and play it here and show you what happens. You see they both fall, they hit the ground, they stop. So this is my guy with a BoxCast. So I move him over. You see right before he gets to the edge, he's still hanging on there. But as soon as he goes over, he falls, which is pretty expected. Now if we cross over this little gap here, does it just fine and smooth. Everything works. Now let's go to the line cast. So when the line cast gets about halfway, it falls off. That might be what you want. That might be okay. But when you run into things such as gaps in your terrain or little crevices such as decor or whatever it may be, he'll actually fall through, and that doesn't really make much sense because, as you can see, he doesn't even fit through the hole. So that's why I'm going to use BoxCast for this and show you how to as well. So starting fresh here, all I have is the update function, and disregard my coding. I'm going to keep it pretty to the point. I'm not going to really use accessors or anything like that. I'm just going to get it done. So we need a boolean first. We're going to call it grounded. That's going to be true if they're on the ground, false if they're not. So then I need a method, check grounded. This will be responsible for checking if our player is grounded. So I'm going to call check grounded first before I accept any input. And then from there, I'm going to do if not grounded to alter the position of the object just slightly. And this is just to simulate gravity. Notice I did vector minus 5 times delta time. Okay. So this is going to check for a jump, spacebar, and is grounded. I'm just going to copy this, make my life a little bit easier. I'm going to change the minus to a plus. And I'm going to remove the delta time because I want them to jump a flat rate. And this is going to actually teleport, but you'll get the idea. It's just kind of a quick solution. Okay, so now we need to actually write the code. So we need a raycast hit 2D that is going to store the results of our BoxCast. So now I'm going to go ahead and show you how to set it up. So the origin is where the cast starts. I'm going to go ahead and start it in the middle of my character. So that would just be transform.position, which is dead center. You'll notice that it is asking for a vector 2. This actually returns a vector 3, but it has an override, so it's okay. You can go ahead and plug it in there. Now the size is how big you want the BoxCast to be. So this is 1 width and 0.5 high. So my cube is actually 1 by 1. So this is going to be half its height and all of its width. So I want to cover all of its feet, but I don't want it to be as tall as the player because you don't want this to hit if the player's head is, for example, right above a platform. You don't want them to get kind of float right below a platform. So moving on to the angle, that's if they're on a hill, you want to cast at a certain angle. We won't be doing that, so that we're just going to leave that at 0 for now. The direction is which direction the box is casting outwards to. So X controls left and right, Y controls up and down. So this would be casting to the right, this would be casting to the left, and we're going to just go ahead and cast down. These are normalized values, so should be always 0 to 1 or 0 to -1. And this is a distance. This is how far you want to cast outwards. So we're going to we have a half height, which is going to consume half of our player box. But keep in mind starting in the center, so that means there's going to be a gap of 0.25 on top and 0.25 on the bottom. So I'm going to go ahead and cast 0.25 downwards. And I'm going to show you more what that looks like. So here's what we have set. Let me move this over here. So we have one width, 0.5 height. This is where the cast box starts right here. And this is about what it would look like visually. So if I casted a distance of 1, it would start at the bottom of the direction you're casting, or the edge I should say. So if I was casting right, this orange would actually start right along here and then move outwards that way. But since I'm starting on the bottom here, it's going to start there and cast downwards. So this would be a distance of 1, which would be the full box, and this would be the distance we put of a quarter, which is a quarter of the box. So that being said, we can just go ahead and check our hit results. See if the collider hit was null or not. And if it's not, grounded equals true. If it is, grounded equals false. It looks like it should work. So let's go ahead and go back to our project. I'm going to add a new player, or just a cube, whatever. Go ahead and add them in there. And you don't actually need the box collider for this. I'm just going to untick it now, and I'm going to drag our new script onto it, and I'm going to go ahead and hit play. And there it goes, it works. Now I'm going to press space, it teleports it up as expected, but if I hit space while in the air, I don't know if you can hear me mashing the space bar, but I am, it's not going to work. One thing that is important though is the floor does need a collider so that the trace can hit it. If you don't have a collider, notice I just unticked it, you will fall right through. And that's it. Easy as those few lines, just right here. That's all you need.